Hello everyone, my name is Guang Wang. I'm a third-year PhD student from Rutgers University. Today is my honor to share our recent work with you. This is an experiment paper which is titled Understanding Long-Term Evolving Patterns of Shared Electric Vehicle Networks. This is a joint work between Rutgers University, SIAT, Chinese Academy of Sciences, and the USTC. I'd like to thank all my collaborators, especially for my advisor, Professor Darshan Zhang. Vehicles build our mobility of the day, and it is expected that the autonomous shared electric vehicle will shape our mobility of tomorrow. Even though it's hard for us to see large-scale autonomous vehicle right now, but we see a significant increase of the shared electric vehicle. For example, the electric taxi, electric Uber, and electric car sharing. And during past few years, we saw a significant increase of the electric vehicle. For example, from about 100,000 in 2012 to over 3 million in 2018. So understanding their evolving patterns is essential for quantifying and predicting the benefits and roadblocks of the future autonomous electric vehicles. Categorized by vehicle type and time duration. Electric vehicle, for time duration, we have short term and long term. Even though we find a lot of work has been done in these three categories, investigate the long-term electric vehicle patterns. So given the promotion and the data science for social good, so this is our work, which is called EPAT. Our contributions here. In this paper, we of the shared electric vehicle to provide the EPAT. The first electric taxi evolving measurement investigation based on 5-year data from 2013 to 2018 from the Chinese city Shenzhen. During the time, the number of electric vehicles has significantly increased from about 400 to over 13,000. And we measure their mobility patterns and charging patterns based on different metrics, for example, the spatial, temporal, and emissions. And we also have some lessons learned for the insights and implications. So this figure shows the electric taxi activity and the charging station location. So each blue circle means the charging station, and the yellow part means high electric taxi activity, and the red part means low activity. And we find in 2013 there are 31 charging stations, and most of and the high electric taxi activity are also in the downtown area. So we found that there is a high correlation between the station location. Then we first investigated the 2015. We found there is not much difference with the phenomenon in 2013. However, in 2018, there is a significant increase of the charging station, and many stations are now deployed in the non-downtown area. And even though there is also a high correlation between the charging station location and the electric taxi activity, but we find that is lower than the 2013 and is expressed to the whole city. So this gives us the first insight. It's about the spatial correlation between the electric taxi activities and the charging station locations. So we found that in the early stage, there is a very high correlation in the downtown area, but in the later stage, the correlation becomes lower, but it is across the whole city. Then we further define the station utilization to investigate where the electric taxi will go to charge. So this figure shows the station utilization in 2013, and the x-axis is the charging, and is the number of charging ports in each station, and the y-axis is the station utilization. So each circle means a station. And we found that in 2013, that the highest utilization station is a very large station with more than 100 charging points. However, in 2018, we found the highest charging utilization stations are deployed in the some smaller stations. So this gives us the second insight. So the second insight is about station utilization and the station size. So we found that in the early stage, the high utilization stations are some large stations, and we further investigation where these stations are located. So we found these stations are in the downtown area. But in the later stage, we found that the high utilization stations are some smaller stations, and they are deployed in the suburb areas. And then we contextualize the electric taxi activity into two stages. The first is the operation stage, and the second is the charging stage. So the key difference between the electric vehicle and the gas vehicle is the charging. So we further divide the charging stage into three sub-stages. Is the traveling to the station, and the waiting in the station, and the service in the station. Actually, we investigate each stage in our paper, but due to the time limitation, I will only show some results. So we first investigate when the electric taxi will go to charge. So as this figure shows that there are 4 peaks in each day, and the highest peak is in about 10 p.m. And there is no difference between there is not much difference between 2013 and 2015. But in 2017, we find there is a peak shift. It's from the highest peak happen about 5 p.m. So we first investigated the reason. We found that in 2017, there is a huge increase of the electric taxis, and many taxi drivers need to return the vehicle to their partner before the evening rush hours, so which causes the peak in the 5 p.m. And we also investigate the waiting time evolving. So as we can see from the last figure, we can show that from 2013 to 2017, even though the median value of the waiting time is stable, but the highest value is increasing. So this gives us the third insight. So it's about the charging waiting time. So in the early stages, charging waiting time is more stable, but in the late stage, it becomes highly uncertain. We summarize our insights here, and for each insight, we have an implication. So for the first one, it's a spatial correlation between electric taxi activities and the charging station locations, so which can potentially guide the government to replace the electric vehicle based on the current stations, which means that how many gas vehicles can you replace with the electric vehicles given the current charging stations? And second is about station utilization and station size, so which can potentially help us to find the optimal location for the charging station deployment. And the third one is about the charging waiting time, so which can encourage us to design some charging scheduling algorithm to reduce their waiting time. Actually, in our paper, we also find some other findings about the contextual impact and the electric taxi benefits for the driver profit and the emission reduction. Finally, I have some discussions here. So for the first one, we can potentially transfer our sensing experience to other cities which has similar features with Shenzhen. For example, the New York City, which is a large city with a large number of population. And so we can potentially provide some guidelines for the future autonomous shared electric vehicles. And for the future work, we are going to investigate the individual drivers' patterns. And we are also trying to find other cities' data to verify the findings from Chinese city Shenzhen. And so we also show our sample data on this website. Thank you very much.
Thank you.